So, you decided to be a naval architect. Terrible choice. But in order to make a ship that works, you need to make a ship that floats. We don't want another one of these, do we? So how do you make sure not to crash into anything while at sea? By steering. As you can see, ships like to turn a lot. There are a few ways to ensure you can safely maneuver your vessel. The rudder has been in use as long as ships have existed, and it's no different in today's age. Rudders are typically found at the stern of a ship, often behind the propellers. Supported at bearings, they have an operating range of plus or minus 35 degrees. When a rudder turns, a pressure differential is created on the other side of it, which redirects the flow of water and turns the ship. But a rudder has to turn, and it's certainly not going to turn itself, is it? That's what steering gear is for. There are many different kinds of steering gears. Some of them have been in use for thousands of years, like the tiller. Others are more modern, but old or new, they can all be separated into three distinct categories: mechanical, hydraulic, and electric. While they're all mechanical, the tiller is separated from its cousins by the invention of the steering wheel. The other mechanical steering gears make use of cable, gear, or chain to change direction. Mechanical steering gears don't make use of any special equipment or principles. They just use the steering wheel to turn either a rack and pinion or a wheel, which are attached to the cable that moves the rudder or propeller. A hydraulic steering wheel makes use of the power of hydraulics to steer the ship. In a hydraulic system, a pump pushes hydraulic fluid through rubber hoses, moving whatever is used to steer the ship. Hydraulic systems require far less physical effort to move than a mechanical system, so they're often used on large ships. In an electric steering gear, an electric motor turns the rudder. They can be fairly complex systems, but are still often used in practice. Over time, engineers have created more and more ways to maneuver the steering gears on ship, like with the Rapson slide or rotary vane, which both move with pressure. The Rapson slide moves in a fixed cylinder with higher pressures than a rotary vane, but the rotary vane has 2 or 3 vanes that can move by pump fluids, which in turn move the rudder stock. Now, all these mechanisms have moved rudders for ships, but look at this ship. This boat has no need for steering gears because there's no rudder. When a ship uses the primary mover to give the ship direction, we call it direct thrust. Perhaps the most common form of direct thrust is an outboard engine. Chances are, you've seen one yourself. Direct thrust allows you to steer directly, but not all forms of direct thrust are so simple. Water jets propel water out at high velocity, moving the ship forward, and azimuthing thruster pods are huge propellers that can be turned without a rudder. And take a look at this cycloidal drive. The world of maneuvering just keeps growing. Now that you know how ships maneuver at sea, you need to know how ships position themselves. The advent of the modern age brought computers, and computers brought ease to ship control. Dynamic positioning makes use of computerized control systems that are able to maintain a vessel's position with its own propellers and keep the ship operating in the safest way possible. Technology has made maneuvering easy enough to traverse the seas, but once they get back to port, they need to be safely moored, which proves a challenge for the largest of ships. Anchors are dropped and dig into sea floors, keeping ships static. For such a simple concept, there sure are a whole lot of types of them. Now, anchors weigh a ton figuratively and can literally weigh a whole lot more. To keep that heavy anchor attached to a ship, a chain is needed. Chains can be made from normal, high-strength, or extra high-strength steel. In order to keep ships connected to docks, wires are attached to winches to pull the ship in. Wires can be galvanized, ungalvanized, or marine-grade stainless, but they must all have a fiber core. Winches turn to pull in or give slack to the wires, and must be designed very particularly, taking anchor, chain, and wire particulars into account. They all run as either hydraulic or electrical. With that, you should be set to be the captain of your own ship. I'm kidding, of course, but at least you know what gives the ship direction and how they stay in place during loading. Good luck on your voyage.